So our goal is to use the concepts of trigonometry and how we create ratios for sine, cosine, tangent, and then the secondary trig functions, cosecant, secant, and cotangent. Notice that they're not in order. So across from sine is not cosecant, across from cosine is not secant, and across from tangent is not cotangent. So keep that in mind. And so we're going to determine what the missing side is. We're going to create a triangle here, and then we're going to come up with the exact values for each of these trig functions. Do me a favor. We're going to make a right triangle, and we're going to pick any angle that's not the 90-degree angle, and we're going to put a little theta there. Now, the first thing we have to know is we have to know, what does sine represent? It represents two of the three sides of a triangle. So the ratio is what over what? You're going to use the words. It is opposite over hypotenuse. So from the angle that I have, I'm going to go opposite of this angle and make a 5, and then I'm going to go to the hypotenuse, which is the diagonal, and make a 7. Now we still have a missing side, and that happens to be the adjacent. I'm going to already write this down. This is opposite, and this is hypotenuse. Okay, now this missing side, I got to figure out what that is, and so we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. And I will tell you that in a lot of my classes, students just assume whatever two values they give you are always going to be the a and the b. The a and the b come from the legs that create the 90-degree angle. So we only have one leg, and we have 5. So 5 could be a or b. I'm going to make the b 5. And I'm going to make the c, because that's always going to be the hypotenuse or the diagonal. In this case, it is the value 7. Let me grab a pen where I have a little more space here. Okay, follow along with me without talking, please. I know 5 squared is 25. I know 7 squared is 49. When I take 25 away from 49, I end up with 24. Now I need to take the square root. Oh, goodness. If you've not done so, please write down these numbers at the top. I'm going to start, and I'm going to call on students to see if they remember. 1, 4. Aaron, what's next? I'll say it for you. 9. Maite, what's next? 16. Lucas. No, not yet. Good guess. Gio, what's next?
25.
And how are you getting these, Gio? We're doing what?
Squaring them.
And what numbers? We're going to go in order. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Here, 6 times 6, 7 times 7, 8 times 8, right? Okay, and now once I have this list, we go 9 times 9. It goes to infinity, right? It goes 121, 144, and so on. We're going to find where 24 is. Here's where 24 lands. And so we never have to check 1, by the way, because 1's not going to break anything down. But we're going to check, can I break this down? So I divided it by 16. It's not a whole number. That's not going to work. Then we take 24 divided by 9. That doesn't work. 24 divided by 4 works. 24 divided by 4 works. It's essential at this level that you break it down. So here's 4 and 6. We know the square root of 4 is 2. So I'm going to come up here, and I'm not going to write the square root of 24. I'm going to write what it's equivalent to, 2 square roots of 6. I'm going to go through this in a very systematic manner. I know the sine is 5 over 7, so I go 5 over 7. And then I'm going to circle when I've evaluated it in its simplified proper form. Now this is a really easy one, because here's the sine. So now I find what it's related to, which is cosecant. I know these two are related because they're reciprocal, so I get to come down here and write 7 over 5. Easy enough. Okay, next I'm going to go with cosine. Now cosine is going to be the adjacent over the hypotenuse. So I'm going to write down the adjacent. Adjacent is 2 squared roots of 6 over 7. And now I'd like everybody to grab your calculator. I see 3 different numbers here, 2, square root of 6, and 7. 2 of them are what I'll call like terms. 2 and 7 are in the same form. There's no square root. We need to see, can this be reduced? So I say 2 divided by 7. I hit math, fraction, enter, enter. I still get 2 over 7. That tells me it cannot be reduced. And this is in the reduced form. It's the correct form. Then I come over and I'm like, okay, of the remaining, what is related to cosine? It's secant. And so these two are reciprocal. So I'm going to write down 7 over 2 square roots of 6. Mathematically, that's not wrong, but it's not in proper form. Proper form says take this value and throw it up top. And once you throw it up top, we're going to write that 6 down below. 2 times 6 is going to be 12. But in case you are not good at reducing, let's try 7 divided by 12. math, fraction, enter, it does not reduce. That means this is in simplified form and it's the correct form. Okay, let's go on to tangent. Tangent is going to be opposite over adjacent. So 5 over 2 square roots of 6. Now before I even go ahead and write that in proper form, I know that for cotangent, the only remaining trig function, I just need to flip this. So 2 square roots of 6 over 5, and then 2 over 5, if you weren't sure, 2 divided by 5, we can see that it's in simplified form. I get the exact same. So I'm good right now. The only thing I have left to do is I need to go to tangent. I need to write it in a better form. This needs to go up top. So I have 5 square roots of 6 and then 2 times 6 in the bottom. So I have 5 square roots of 6 over 12. And then I got to make sure 5 over 12 cannot be reduced. It cannot be reduced. That is in proper form. So all we know is we know the tangent of an angle is equal to 6. That's all we know. And we're going to use the Pythagorean theorem to determine what is the third side. And you may be going like, I don't know what she's talking about right now. And then we're going to find and identify all the 6 trigonometric functions. Okay, always start by making yourself a pretty right triangle. And then one of the 2 angles, we have 2 angles that are not right angles. We're going to choose one of those 2. It doesn't matter which one we choose. And we're going to make and put a theta in that. That's going to be the angle that we're going to use as a reference angle. Okay, are you ready? So what can we put underneath any single number and it doesn't change the value? A 1. We can always do that. So I know tangent means opposite over adjacent. I know that. So I'm going to go up to my angle and I'm going to go, okay, what side is opposite? Opposite is right here. This is the length that's opposite, so I can put a 6. And I'm even going to write that in. This is opposite. I know this is hypotenuse. That means this has to be adjacent. And the adjacent is going to be 1. Now we need to figure out what is the missing length. Well, the missing length, that third side, is the hypotenuse. So I'm going to say a squared plus b squared equals c squared. Okay, here we go. This time I happen to have both legs. A and b are always the legs that help create the right triangle. It doesn't matter which one, if the 6 is the a or the b. 6 squared plus 1 squared equals c squared. 6 squared is 36. 1 squared is 1. And now we have to see, can I break that down? I'm going to really quickly write these down. They should already be on your paper, but I'm going to write them down quickly. Okay, well 37 is just past 36, so let's see, can we break this down? So I'm going to take 37 divided by 36. If I don't get a whole number, I just keep going. 37 divided by 25, 37 divided by 16. We can see none of these are working. And I don't need to worry about doing 1. That doesn't break us down. Okay, that's in simplified form. This is the square root of 37. How do we go about doing this? I know a lot of you are not done yet, but if you're watching this video, we are together in class are now going to identify the exact values of the 6 trigonometric functions. So let's start with what we know. We know that tangent is 6 over 1, so I find tangent, and that's 6 over 1. Done. Same thing as 6, by the way. 6 over 1, same thing as 6. And then I get to find the reciprocal, which is cotangent, and I'm simply going to flip it around. Easy enough. I've got 2 out of the 3. They're done. Okay, let's go on to sine. So I'm going to write this just for my own benefit. Oscar had a heap of apples. So I know sine is opposite. It's a ratio. I'm taking 2 to the 3 sides of a triangle and I'm comparing them in this order. The opposite length over the hypotenuse. Okay. Find sine. Here it is. Opposite over hypotenuse. So from this angle, opposite is 6 and hypotenuse is the square root of 37. Now I'm going to come back to that. I know that there's a relationship between cosecant and sine. So if I take the reciprocal square root of 37 over 6, I've already checked, can I break this down? I can't break it down any further. This is done. Now up here, mathematically not wrong, but we're not going to see it like that at this level of math. We need to rewrite this as 6 square roots of 37 over 37. And then we're going to take the 2 values that are alike and I'm going to divide here. And I want to hit math, fraction, enter, enter, and we can see that it does not reduce. This is the simplified answer. Okay, cosine is adjacent over hypotenuse. Okay, so from here, adjacent is 1. Hypotenuse is square root of 37. I'm going to flip that around. I know I can't break that down, and then I'm going to rewrite this in correct form. 1 squared to 37 over to 37. 1 and 37, you can see when I plug it in, that when I plug it in, it does not reduce any further. These are my 6 trigonometric functions.